All right, so you should have gotten from the sub a small periodic table like this. What I'd like you to do is go to your next 2 clean pages. You're going to orient your journal this way, so kind of sideways. And I want you to take some glue or some glue stick, and you're just going to, just a little bit, you're going to glue it on the top, okay, like that. And I want to talk to you today about how the periodic table is set up. There was a scientist called Mendeleev, and he did something similar to what you did. He put together element cards, and he wrote information on the element cards, and then he laid them out, kind of like we did yesterday. We laid them out. And what he began to find was certain elements had certain characteristics that were the same. So he started organizing them or classifying them according to how they reacted, whether they were metals, nonmetals, or metalloids. And what he came up with was this table of elements. Again, his name was I'm going to have to go check the spelling, but I think it was Mendeleev. You can look him up, or maybe I'll have you watch a video. Anyway, interesting guy. What happened when he laid them out? This is what he found. He found some of these elements have the same reactivity or behaviors when they get together. And so he put those in what we call groups. So I want you to draw here a column. All right, so this is called a column. You might see that on a test, right? And we're going to do this first column, so put a number 1, and we call that a group. These are all called groups. So there's group 1, and then you're going to see a 2 here. That's called group 2. And then you're going to see group 3. And really, that's going to go group 3 through group 12. I'm not going to draw those. All right, so these are called groups. And groups go up and down. Okay, groups go up and down. Okay. Here I want you to go here to group 13, group 14, group 15, you're drawing this in your notes, group 16, group 17, and group 18. Okay, so there's 18 groups. Groups go up and down. These groups have similar, and you're going to see that on a test, similar characteristics. And what that means is they're going to have the same valence electrons. So if you look at group 1, hydrogen, lithium, sodium, potassium, everybody in this group is going to have one valence electron. That means they're going to have one on the outside ring. We kind of saw that yesterday when we put our periodic table together, where your hydrogen, your lithium, and your sodium all had one in the outside ring. What was changing was how big they were, right? How many orbitals they had going around. Group 2 is going to have 2 valence electrons. Please write this. Group 3 through 12, if you look at these elements, here we have iron, we have gold, we have silver, we have copper. These are all metals that are found in our Earth, and they do not tend to react. So we call these, well, I guess we could write it here. We call these the transition metals. And we talk about compounds being formed like sodium chloride. We're not going to find compounds form as readily with these metals. So when we talk chemistry, we're mainly looking at groups 1 and 2 and groups 13 through 18. So group 13, we know that it can't have 13 in its outer ring. But if you drop the 1 and only look at the 1's place right there, group 13 has 3 valence electrons. Group 14 has 4 valence electrons. Group 15 has 5 valence electrons. Group 16 has 6 valence electrons. Group 17 has 7 valence electrons. And group 18 has 8 valence electrons. I'll let you catch up. So everything in a group, right, has similar characteristics. It's kind of like if you're in a group, right? You may hang around with people that are all in the same sport that you do, or maybe you're an artist and you hang around with other artists, or you play in the band. Same thing with elements. They're put into these columns called groups. So on a test, if it says, who's going to act like hydrogen, you're going to pick anybody from that group. All right. On the periodic table, you'll also see numbers other than the numbers here at the top, right? They tell you the groups. Actually, if you look here where it says like 3A, 4A, that's another way you can tell how many valence electrons or electrons on the outer ring that they have. So 3 on the outer ring for boron, 4 on the outer ring, 5 on the outer ring, 6 on the outer ring, 7, and 8 on the outer ring. We also see other numbers out to the side here. And we have a 1 here, and a 2, and a 3, and a 4, and a 5. These are called periods. Sometimes they call them rows. Now, periods and rows go across, ooh, you know who I left off over here? Helium. Ooh, put helium right here. They go across. So hydrogen and helium are in the same period. So let's go down here to our notes and write periods go across. Hydrogen, helium are in the same period. And let's add row to that. So we have ways to identify elements, right? So we have periods and groups. So I might say to you, which element is in period 5, group, 13. So you would say period 5, group 15. So we're going to go over here to the group, and you would say antimony. What element is in group 1, period 3? Group 1, period 3 would be sodium. Now, here's the cool thing about periods. Groups tell us which elements have similar characteristics or alike. These periods will tell us how many energy levels they have. So if you look, like yesterday when we did our cards, we kind of pointed out that hydrogen and helium had one energy level, didn't we? And if you looked, lithium has 2 energy levels. So lithium, and then over here, neon, right, would have had 2 energy levels. And then when you did sodium, you had to make, why am I doing that? Don't do that. Do it right here. 1, 2, 3. You had to make 3 rings for sodium, remember, and it had 1 electron on its outer ring. Well, over here, in that same period, argon, it had 1, 2, 3. So these periods tell us how many orbitals. If you were to have to draw potassium, like my advanced students, what they found was potassium had 1, 2, 3, 4 orbitals, and potassium had 1 electron on the outer ring because it's in group 1. So our periodic table tells us quite a bit about electrons, valence electrons, and how many rings are needed for their orbitals. Our periodic table also has atomic numbers, which identifies which element it is. So this periodic table is like the dictionary of elements. All right, so once you get all these notes done, and on Monday I'm going to ask to see your notebook, and I would expect it to look exactly like what I have here. So if you need to pause the video right now and make sure that you have all this information written, then please do that. The sub has also brought to you a kind of a worksheet interpreting the periodic table. It's going to ask you some questions about the periodic table. You're going to complete that and turn that in for today's assignment. All right, have a great Friday. Have a great weekend. And on Monday, my expectation is that I did not see anybody's name on the sub list and everybody got their work done, because next week we have a Unit 1 test on Thursday. So we will do some reviewing, but you need to know this information. All right. Have a great day. Bye.